Greetings everybody. We're going to be looking at Construction 101, Let's Build, which is a video which is dedicated to all those who have an interest in construction. Basically, we're going to be looking at a simple structure from the exterior view. So join me as we analyze the parts of this structure. We're not going to look at an entire building in detail, but by the end of this video you should be able to identify the key features or the common features of a building or of a residential building. Let's start by looking at the site preparation or preparation of the site. So let us see that note in front of us. After the approval of documents by the relevant authorities and site awarded for construction, then site preparation will commence. So we have to first ensure that the relevant documents go to authorities, local authorities, or the relevant authorities who are supposed to approve the plans, the contract documents, and all the like before we start with tampering with anything on the site. Otherwise, that construction project will be stopped, and that won't be good. First of all, unwanted shrubs, hedges, grass, trees, etc. have to be cut down, including grabbing up of roots as stated in the specifications, and that has to be done according to the dictates of the law, according to regulations from the authorities, relevant authorities in the area where the site is located. After the site is cleared, all anthills and termite nests should be removed, including searching for the queen and introducing environmentally friendly insecticides assisted by specialists. So a specialist has to be involved in order to make sure that these insects are removed safely and we are not polluting the ground or the environment. As specified in the approved documents, storm and surface water should be drained and removed prior to the stage of excavation work. You are going to see that we're going to be dealing with, for foundation, we're going to be dealing with what we call strip footing, which is concrete. We use concrete for the strip footing, we call it the strip foundation. It does not want any presence of water in the trenches. So from the start, we just have to avoid water at all costs. While working on this stage, everyone on site should ensure they adhere to the safety precautions and wear appropriate gear, or what we call the personal protective equipment, which is the PPE in short. We are now used to PPE in COVID. We also have PPE in construction. It's just personal protective equipment used to protect those on site, whether they are working on the project or they are visiting. You just have to be safe. Just like we have color codes to ensure that we identify people who is working on the project. Usually visitors are supposed to wear white hard hats or helmets to protect themselves from anything from above. And if there is a provision for hoarding, there also has to be that. Boundaries have to be set. All that is part of site preparation. If there is any introduction of offices on site for the relevant professionals who are going to be working there, that has to be provided, and that's part of site preparation, just so that we are ready for the construction work and everyone will be ready to start their job on site. Okay, so moving on to excavation to remove topsoil. That's the first part of excavation. So we have the natural ground level, which is the ground that is now leveled. We have to level the ground after cutting down the trees and removing all those other vegetation that's unnecessary on the around the or rather inside the building lines. We have what we call building lines. Yes, go and find out how local authorities determine the size of the land that's going to be used, or the area of the land that's going to be used for the construction of the building. So we have that area. So in that area, the ground has to be leveled. That's what we call the natural ground level. We can level it by what we call cut and fill, where if you have highland and lowland, you cut the highland and you fill in the lowland so that the land is leveled. Okay, after that we then remove what we call the topsoil. Where we want to construct the building, we remove what we call the topsoil, which is around approximately 150 millimeters from the natural ground level. And when you see later, that's where we put what we call, we replace that topsoil with what we call the hard core. mixture of approved material that's needed to be put there for the structure to have a good firm foundation, well compacted hardcore for a stronger foundation. So that's what we replace in that area where we have removed the topsoil. So we remove the topsoil, which is 150 or approximately 150 millimeters, depending on the specifications that have been provided by the designer. So after topsoil removal, we then go on to excavate the trenches. So we excavate the trenches, and the designer, who can be the architect or the engineer, they specify in their specifications on their plans or general specifications how we're going to measure the depth and what the measurement is for the depth of the trench. So either we're going to do it on site when we are now constructing, or it has to be provided by the designer. That will be specified in the specifications. So we just follow what is in the specifications. You see that that's basically what the contractor has to do. The contractor is the person who undertakes the project, as we saw in the previous video on the introduction to construction. So this is why we have that bracket which says trench depth. It's showing how the trench starts from where the topsoil ends, where we remove the topsoil, that 150, from that point going downwards. That is the trench depth, where we say we are excavating the trenches. And take note that we won't be excavating a trench or removing the whole all the soil from the topsoil removal all the way down with the entire area. It's just a certain width of the trench that we focus on, which we call the trench width. Usually, according to engineering calculations, the normal standard is for the building to have stability and all that, you have to have 45 degrees on either angle, or rather on either edge of the trench, and that is also determined when you ensure that the trench width is triple the width of the wall that is going to be constructed in that trench. Yes, so that's how you ensure that you have that 45 degrees. It's basically an engineering standard that has been set, so just follow that and ensure that our buildings are stable. Before we continue, I hope we had a chance to look at this illustration from the previous video, the introduction to construction video. So I'm not going to go into detail with all these parts because they're already detailed. If not, then you can just go through it, but I'm just going to go through the order of construction. It's basically logic. You start from the bottom going up, but maybe you might get confused, so let me just go through it quickly. So we start with the concrete strip footing, which is what you see at the bottom there with the triangles and the dots, basically representing the coarse and the fine aggregates, mixture of coarse and fine aggregates, and the cement and sand. Yes, that's represented by that. I think the symbols and the color codes, you saw them from the previous video as well. So if you're not, please go and visit that video. Very specific on those. It's very specific on those symbols and color codes, and you might get to understand more when we start talking about it here. And then from there we go on to what we call the sand blinding, which is basically let me say 10 millimeters, I think, or less, of sand that's put between the brick wall that you see. The brick wall is the next thing that is put, and the concrete strip footing. But before we go on to the brickwork, we have to make sure that our sides are, the sides of the trenches are not going to collapse on the people working inside the trench. So making sure that anything doesn't come into the trench from the sides of the earth or the sides of the trench. So after that, we then construct the brickwork, or what you call the brick wall. We use industrial bricks for this one because industrial bricks are stronger, they're fire resistant, they do not allow water to seep through in, or they don't absorb water easily. So their strength is very, very we can trust their strength in the foundation, and the foundation will last long. In some cases, rather in some countries, the standard duration or the standard lifespan of a house should be around 60 to 100 years. So you need a very strong foundation, and industrial bricks have proven to be very good at that. So we use that, and then we put what we call backfill. So remember, when we excavated, we removed soil, and we put it somewhere. You usually see some heaps of soil where people are constructing. Yes, it's the soil that has been removed, topsoil and the trench soil. So some of it is put back, but we also put other material that is approved. Okay, so with the backfill, I think we can see with excavated soil and other approved earth material. That's basically it. Then a quick note: you see the trench width here is 690, and the thickness of the wall is 230. If you multiply 230 by 3, you get 690. So that is what I meant when we were talking about the trench excavation, how you need to have a spread of around 3 times the thickness of the wall. It's for that engineering. It's basically the forces and all those things, the dead laws, the forces, how they affect the trench, rather the foundation in the trench. That effect has to do with some forces and the weight. So that's catered for when you make it 3 times the thickness of the wall. So after the backfill, we then move on to the hard core. So the hard core is with the other approved material again. That's the one with the zigzag, the triangle looking part there, as you can see. That's the hard core that follows backfill. Then from hard core, we put on the sand blinding, and then from the sand blinding we move on to what we call DPM, which is the damp proof membrane. It's in the name. The damp proof membrane runs from that part to the sides of the wall as well. It's just trying to ensure that moisture in the concrete does not move to the wall, and moisture from the ground does not move to the concrete, yes, vice versa. And then from the DPM we then move on to the concrete slab. So we then put the concrete slab. It can be in situ, it has to be in situ actually, and you have to cure it for 28 days to make it firm and hard and strong enough to hold all forces that may come upon it, whether imposed or dead laws. So for walls, we have many types of walls. We have monolithic walls, curtain walls, framed walls, masonry walls, which is the most common used type of wall for residential buildings. That's the masonry wall. But before we put the walls, we first have to put the DPC, what we call damp proof course. DPC, it's put on top of the brickwork in the that we saw in the substructure, on top of it, and then on top of it we then build that masonry wall. And as you can see, we have the rectangles hedged with red strokes represent the single units or bricks that make up the masonry wall. So masonry wall can be of stones or bricks. It has to be single units that are bonded together to form a wall. That's basically the masonry wall. And then we have the white lines, which represent the brick force. The types are provided in the specifications. So this brick force is put between bricks. The brick force is used to reinforce the brickwork, and in this diagram it is put after every second course of the brickwork. So the courses are like the rows of the bricks. Yes, the rows of the bricks. Okay, you may be wondering why we have those broken lines at the sides. Basically to show that we cut the wall. It's not the entire wall that we're looking at. We're just looking at a segment of the wall. And let's move on to the right side. It says the air brick with mosquito wire gauze. So air bricks are usually built in. We put the air brick as we're building, and usually as the mosquito wire goes, I think that makes sense. We can't have mosquitoes entering rooms, so we put wire gauze inside the air brick, and also it allows fresh air to come from outside when all doors and windows are closed. Then we have gray lines, which represent the pointed mortar with thickness of about 10 to 50 millimeters. Pointing usually means the finishing of the, those parts where you see the mortar of the cement and sand that's put between the bricks. You don't want it to look junky, so you just smoothen it and use something to make it smooth and have a nice finishing. You can make it as a groove, or you can make it flat with or uniform with the bricks, or you can make it in any way aesthetically presentable. And then we are being shown there the first and second course of the brickwork. Basically we count from the bottom going up, and and yeah, we already talked about it. It's the cement and sand mixtures. They're all provided in the specifications. It's also according to the designer's specifications. Usually engineers are involved in this to ensure that the strength of the building is achieved, the target strength of the building is achieved with the use of the materials and their mixtures. And then looking at the bonding of the bricks is like how the bricks are arranged. So that one is called the stretcher bond, because the stretcher is like the length of the brick, then the width of the brick is called the header. So the stretcher bond, that's the length of that brick. And we have many other types of the English bond. That English bond, you can look at the bonding or the walls of the number 10 Downing Street in London. Number 10 Downing Street in London, the Prime Minister's office. If you look outside, that black wall, the black masonry wall, it has the English bond. That's what we call the English bond. And it also suffices to say because it's the English country. So that's the English bond. And then we have what we call the Flemish bond, and many other types of bonds that we're not going to look at right now. But this specific one in this video, we call it the stretcher bond, because it's just alternating positions of the stretchers of each and every unit. Another point is these walls have to ensure that there's a good balance of atmospheric conditions from the outside and the inside of the building. And also these walls have to be fire resistant. You don't want your walls to bend down with the building. That would be a very painful loss, because it means you can't repair those walls. But if they don't bend down, they stay intact, then maybe you can be hopeful that you can replenish them after that after the fire incident that might occur in the future. These are inevitable. You never know what will happen, but at least we better be prepared for any external conditions and the changes like global warming and heats and all that, temperature changes and even fires. We have to be ready for the effects that come with those dangers. Okay, so after the building of the wall, we now look at plastering the masonry wall. So maybe you're not so satisfied with the masonry outlook, so either you can put facings in front of the walls that you've already built just for aesthetics, but maybe if you're not satisfied, you can plaster your wall. And we have the first coat, which is also known as the scratch coat. Basically, we just scratch the surface of the coat after applying it onto the brick wall, and scratch to allow the coat to bond easily with the brown coat. So the brown coat is a sticky second coat. It's made sticky by water. Water reacts with the components of the plaster and sort of becomes sticky when water is increased, when it bonds with the components or reacts with the components of the plaster. And that's what we call the brown coat, and it provides a flattened and leveled surface for the finishing coat. Actually, you have to make sure that it's flat. It doesn't level itself by itself, but you have to ensure that the surface is leveled, and it's also sticky for the other coat to also come and bond well with it. And before applying the next coat, you have to ensure that at least the previous coat is sufficiently dry, or it's very dry, so that you don't have defects. There are many defects that even you can see the difference in the layers of the plaster, or it might even start peeling off because it's not bonded well. You just need to ensure that it's sufficiently dry, or it's able to just bond with the next layer. So then the other layer, which is the final one, is the finishing coat, made smooth by using a float. We have a wood float for external walls and steel float for internal walls, and it is important for it to be a smooth surface which is aesthetically appealing. Some buildings, they just finish with a plaster, they don't put any other thing, it's just plastering and they're done. So you need to ensure that it's smooth and level and presentable. You do that with a steel float for inside and a wood float for the outside, because wood float is sort of rough. You might need a rougher surface for the outside, and the steel float is for the inside. Steel makes it smoother than the outside, because usually people are focused about the interior design. They're not so much focused on the exterior, because the exterior is more of resisting external elements and external conditions, which is not really good for aesthetics, but at least a wood float can make it look presentable. A float is basically like a plate a plate of certain material. It can be wood or steel, and then there's a handle which is stuck on it or attached to it, which you can sort of like you grab the handle and you brush it on top of, or rather spread the cement or the mortar or the concrete or whatever that you're trying to level. You just spread it around and ensure that you have a leveled surface, or a smooth leveled surface. That's basically the use of float, and that's basically plastering. And the components of proportions of the components of the plaster will be provided in the specifications. Okay, now we move on to painting. So we have what we call so basically let's start with the plaster. That's the final layer of the plaster is the finishing coat. This layer has to be cleaned and thoroughly prepared for the application of the paint to avoid unnecessary defects that may arise in the near future. So we have to ensure that, one, it's dry, very dry. The other part is we also have to ensure that it's smooth and leveled, in order to make sure that the primer coat, which is that primer, the first coat, which is normally white, since white contains or reflects all colors. When that primer is applied, it has to be applied on a smooth surface, and because that's now the final outlook of the building, we have to ensure that it's now smooth, and we have to ensure that from there onwards everything is smooth and leveled and aesthetically appealing. So like the primer part says, that note, it says that the primer has to be white because white reflects all colors. I think that's very, very common. Even the sun, the color of the sun is white. Lights in your room are usually white, unless if you have those LED lights and all these other fancy lights. But usually with white light you can see everything, and it won't distort the color of the other or the shades of the other coats that you're going to apply. Then the second coat is also the first color coat. That's when you start introducing color to your building, and it's used to the color used will be specified by the designer or in the specifications. In some cases they use yellow, but yeah, it's specified in the specification, so you just need to check, because sometimes it might depend with the final coat also. You won't want to distort the color of the final coat, so you have to also ensure that there is some agreement between the second coat and the final coat. And now looks like our house is beginning to take shape, eh? Okay, so now we move on to the openings. The openings are basically those parts which can be opened to allow fresh air to come in, or to allow sunlight to come in. Basically, it's the access of stuff that's outside the house to enter inside, and what's inside to also exit. That's the purpose of the openings. So we have the window. A window with a type and dimensions as stated in the manufacturer's catalog and the building specifications. It is either built in or fixed in. The same thing with doors. So these two openings, what happens is the built-in windows and doors, it's basically you put the window there where it's supposed to be, and then you build around it. You put your bricks around it, and you lay your bricks and the like. But with fixed in, you just leave the opening as you're building the wall, and then you fit in the window and the door. That's the fixed in part. So that's how we put them in. And the parts of the window, we have the head, we have the frame, we have the windowsill, we have the lintel that's above the window, which carries all the load so that the window does not carry load. The same thing with the door, it also has its own lintel. We are trying to make sure that these windows and doors, they don't break or you have to suffer any loads on them. But that's basically a rough idea of the openings that we have. I know there are people who are going to be very analytical and very observant, so for the sake of those people, I just excluded the doorstep, but it's supposed to be there. Just include it as you are imagining that building. Just include the doorstep. Now we move on to roofs. Let's not look at how that roof is looking like, as I know it's not aesthetically appealing, but it will serve the purpose of making us understand the parts. Okay, so we'll start from the top. We have the ridge, which are parts of the roof. We have the ridge, which is that top part of the roof, and then we have the roof covering of rafters. The rafters, as you can see, those are the diagonal planks which meet at the top at the ridge. And then we have the pitch, which is that angle between the ridge and what we call the roof tie beam. The roof tie beam sort of supports some loads, carries some loads on behalf of the wall, or it helps the wall with carrying some loads. And then we have the brandering. As you can see, that's like the branding is basically planks of wood that are lined up normal to the beam, to that tie beam, and they are there to carry the roof, which is on top of the walls. So it's the branding that's on the walls, and then comes the beam, and then the trusses and all that. So we also have the trusses. Those are like the structures that help with supporting the forces that are imposed on the walls. The trusses are there to ensure that there's a balance of forces in the roof. Yes. So that's the job of a structural engineer, to ensure that those trusses are enough and they are stationed where they're supposed to be stationed, so that there is a balance of forces in the roof and the forces are shared in all the trusses, and that helps with a balance of forces also on the walls, with transfer of loads in the walls, so that the building does not have to, or rather the walls don't have to feel weight or unequal weight. You might find that some walls on one side might feel like they're carrying heavy loads and the other ones are not carrying a lot. That won't be a good sign for a required sustainable building, or required long lifespan for a building. It might actually affect the lifespan of the building when the loads are not balanced. So to show how these trusses will be stationed according to the specifications from the structural engineer, the structural engineer is to provide what we call the roof plan, which shows how he or she has calculated the forces of the trusses and what they have determined is the correct distances between the trusses, and how the pitch affects the positioning of the trusses, and all that it's included in the roof plan, and it will then help the contractor to ensure that the exact positioning of the trusses and of the roof and of the rafters and of the beams and of the branding, everything, that it's stationed where it's supposed to be in order for the roof to serve its maximum purpose. So we're done with the construction. Yeah, we have constructed our first building together, and hopefully we'll construct more. I'm looking forward for us to be looking at basements next, and story buildings, skyscrapers next, and then we'll even get to look at mansions, and then even get to construct roads and cities and all that, and hopefully we'll even get to venture into the metaverse. The metaverse might actually help us to do these things together, but yeah, it's just dreams and dreams. Hopefully they'll come to pass, but we have done the first part. Hopefully this will help someone, but yeah, before we end, just attempt that question, or rather that instruction. Just try to identify and name all the parts of that building, and let's see if we have understood something. At least you have to understand something. You can't just be hearing from me all day and you have nothing that you have received. So pause the video and then try to attempt that and label the diagram. Just identify the parts that you are seeing and name them, and then you play the video and see if you have understood and if you have gotten anything correct. As for me, I think we are done. We'll meet next time. So after this, just if you have gotten everything correct, I congratulate you. If not, try next time. Maybe you'll get it next time. but it's just good for you to know the buildings that you are living in, that you visit, that you stay in, so that you understand the work that was put in by someone to ensure that you have some shelter, some good shelter, that you can say, wow, I live in this house, I live in this place. Someone had to sweat, someone had to work, someone had to run around to ensure that your stay in that building is good, and such that you enjoy the shelter that they have constructed for you. As for me, I think we're done. We'll meet next time. I already said that, I don't know why I'm saying it again, but yeah, we'll meet next time when we discuss the buildings. Cheers.